haven't thought about him for a long time. I should go back and watch some of their stuff. Good family entertainment. All right, let's see. So this was let me so we had so where I'm at with my screw conveyor is I had started a part, right? So this is actually my part, and I had done a little flat pattern checking with it, and it was kind of working. I could see that my flat patterns were going to develop. Then I decided I wanted to change my solid. So really, I delete so my part was like SC004. I deleted the flat pattern and I deleted my part, my thicken that I had done. So I'm kind of back to square one here. This is where we were. So I've really deleted my steps. And the only thing I'm back to is that I had derived the original solid in right here. So this is my original solid that I decided I had maybe some issues with because the face wasn't broken up how I want it to be for the discharge chute. And so if you were following along with me, you'd probably done some thickening and then we had checked the flat pattern. I just went ahead and deleted that stuff off my model browser. So I just selected it over here and just deleted my flat pattern. Then I deleted my thicken and I'm back to almost like no parts on my part here. Um, and that's where you're seeing me. And so what I'll do, maybe I'll just do that real quick and I'll go back to where I had it thickened. So just bear with me for a minute. I'll put this back to what we had done in this part was I had thickened these three sides to the outside. I put in thickness here, right? Because this is a sheet metal part that we've established a sheet metal default to. We did that together. So by typing in thickness, which is a legit dimension, that's just the thickness that is preloaded in the defaults. And so, which is 0.1094, 12 gauge. And so we had this part like here. Oh, and I even had maybe it's deleted everything. Let me just check my sheet metal defaults real quick. Yeah, I'm just gonna load mine real fast because you should have had this one loaded that we came in here and we set that I started a new one and I said that it was 12 gauge stainless steel. And so I created a new sheet metal rule, right, for 12 gauge stainless steel. And on that one, if I double click this, I think it goes blue like it's selected. And then we change this to stainless because this is one place you can do it, which kind of overrides your top little toolbar there. Stainless steel. And then I needed to tell it what it doesn't know what 12 gauge is, but I do. It's 0.1094. So we had this one loaded. Then I just saved and closed this, and I made sure that's the one I'm using. It shows up on your drop down here now, right? So that's the one I've got. And it changed everything to that. So this is where we were. I decided I didn't want that part of the chute to be part of the housing here. And so this is when we went back and I made a copy of my solid and I reworked it and I was happy with that. Um, a couple of troubleshootings with that when that happened. I'm going to open up that other solid now. So I'm just going to go to my home and open up that new solid that I created, which I called S2, a solid 2. And so I ended up having these multiple faces here, which is what I wanted. And then this is one way to have done it. I could have, yeah, there's other ways I could have done this for sure. I just jumped into something that would work and created new solids too, right? So now I have like in my new solid, I have like what I think I have seven different solid bodies. I kind of have, which maybe I'm still not done messing around here because what I was kind of working through. So I'll start here again on my on my new solid, my copy solid. I'm just gonna go through and kind of separate these, make sure I don't have multiple kind of parts that I'm going to create individually, make sure they're not attached to the same solid. So what I'm seeing on mine is I still have this flange here. This lower flange seems to be part of that solid that's the housing. So I'm going to separate that in that, particularly this flange. Sorry, I'm not broadcasting yet here, but I will. Windowed. You gotta keep me in line here. Let's see. So I'm going to do just a little bit more to separate these solids. This one here, as I'm happier with this. This is the one that I spent a little time and it blew up on me a little bit to create that little drop down chute, discharge chute as a solid. Got it.
You go to thicken those, it's gonna like thicken the box instead of just the outside surface. Or that,
It should thicken just the surface as the surface face. Yeah. Exactly. That's a good question. Yeah. And then I've got my end plate as a solid. And then I've got this solid, which is I only drew one of those. And then I've got this solid, which is this inlet flange. And then I've got my end plate here as a solid. And then I think Riley told me yesterday that I didn't make this 3/16, and I can see that it's not. They're like matching. And really I had 3/16 flanges that go against the housing, and the end plates were the only thing that were 1/4 inch at this point. So this one I'm going to do a quick ch change of my I think you said that I said 3/16. I just never changed which is this particular extrusion on mine. I just want to make sure I'm going to double check this, do an edit feature. And yeah, see, I didn't ever change this to 0.1875, which was 3/16 of an inch. So if you followed me or you're watching me on screen, I didn't catch that that I didn't change that to 3/16. So that's 3/16. This is 3/16. That's going to be 1/4 inch. Over here, it's kind of the same pattern, like 3/16 for this, 3/16 for this one, and then it's 1/4 inch end plate. So there is kind of a systematic material sizing here. And so the only thing, so I'm really happy. The only thing I've got is I think I need one more solids. I really think I should end up with 8 kind of solids, like 1, 2, 3, 4, 5, 6, 7, 8, and I only have 7. So the one that's still connected is this one. So so all I do is make that a new solid. And so I'm going to come to find that extrusion. Of course, I'm not labeled yet, so it's harder. I just got to scan through and figure out this is when I did that extrusion. It was my third extrusion of my set. It's if I go in here and edit it, all I'm looking to do is create a new solid. So it's not hooked. If this shows when it goes like this, you'll probably already learn that that shows those two solids are joined, even though they don't even touch each other. Well, let's just make that a new solid. It'll be my eighth solid in this base component. Yeah, I'm gonna accept it and see what blows up. I think it's mostly just gonna be the holes, maybe. Right, that hole. It just doesn't know that they go through this new solid. So I just got to edit the features of the holes, which is just going to be a matter of unselecting the solid that it's originally tied to. So I just X those out. And then I'm just going to pick the new solid that it goes into, this one. So that's actually, nothing wrong with sketches or anything with that. It just doesn't know. Once you change solids like that, it really impacts, how the feature works. So then I say, okay. Now I've got a pretty happy model browser. I don't have any exclamation points. I don't have any sketches that are yelling at me. I'm going to go into this one sketch and just talk through some troubleshooting just a little bit. So the one that we had to mess with a lot were these ones originally, creating that new solid. So it was the same extrusion. I'm just going to open up the sketch of it and just talk if mine's all constrained, but just remember, like when you're troubleshooting, like I'm trying not to delete things that solids have been created from and cause some big domino effect, especially if this is like further along in the design process that I've got dozens of parts created from this. I have to really be careful not to delete so that, our bad habit of just deleting and starting over can really affect solid modeling for sure. So we tend to have to work and break constraints more, which is painful, but sometimes I have to get into these lines and collect these and select these points and get on these constraints that show up like this, even this one. And once you're on them, you can choose to delete them. And so all the time when I'm troubleshooting this, sometimes I'm just breaking some of the corner constraints off stuff, and I get it to move almost like I'll get like if I had to, I could delete all these constraints on this and get this particular line to move and kind of flex it so I can tell that it's broken away, and then I can reestablish those constraints. So I do a lot of that. In fact, when I was just helping Kelsey, I was just having to break constraints, go through, nitpick endpoints, see things that aren't, vertically and horizontally constrained, and maybe add some constraints if when you're moving stuff around, you can tell that it'll move angularly. So you just really have to get down to the weeds without deleting your lines necessarily and try to break them free. You'll do that a lot if you use Inventor, and I'm sure SolidWorks is similar. But so I just want to maintain the geometry and break these constraints. And then sometimes when I do that, sometimes when I break those constraints, then I have to go and reconstrain. And then so I do like a lot of coincident constraints and I hook them all back together. And things might be going good. And then sometimes what I'll have to do is just check that the polygon is like a closed polygon is what we'd say, right? In order to make any extrusion, we can't have an open polygon with corners that don't come together. And when you're breaking those constraints, sometimes you have to zoom way in to see the breaks that you might not even visually be able to see. So I use this little trick and I've showed a few students this, but that I can check to see if a polygon is closed. So like say for example, I had to break up, you know, I had to break up these lines and kind of reconstrain them. And after I've done that, I can check that they're joined by just selecting one piece of them here, and then right click. And this little closed loop is a just a trick that I use to check if this is going to be a closed polygon. And I use this a lot on because a lot of different shapes it's hard to tell if I'm intersecting correctly or not to make a closed polygon. But if I say, okay, close loop, you'll get this little thing that says select a curve that is connected to the start or end of this open loop. And then you just continue selecting curves until the loop is closed. And it has a little troubleshooter. It'll try to do what it can to solve problems if it finds it, but it can't always because constraints hold geometry. And even the troubleshooter here doesn't, sometimes it'll at least pinpoint where your issue is. So let me see if I say okay on this. This goes to kind of a lighter shade of blue or just kind of a bluish shade. That's the one I've selected. Now it just wants me to select geometry that should be connected to it. So I would think this line should be connected. And then you'll get errors like this. Sometimes there are multiple sketch points where the highlighted curves connect. Would you like to combine the points into a single point? You can say yes. Sometimes it'll say I can't because of the constraints. I'll say yes here. It actually did. So there's how the troubleshooter sometimes works good for you. Sometimes when I click that yes, it says, oh, I can't. It's like a constraint is preventing it. And maybe I got to get back into this area and unconstrain stuff and reconstrain it. But this one helped to fix mine okay for me there. It was like redundant points, it said. And then I'm going to come across to this one. And this one won't even let me select. So it acts like there's maybe it's weird a little bit. Or I don't know what it is. Like I'm selecting there. Yes. And it says I can't do that. There's already a constraint there. And so I'm like, okay, but it won't let me select this. And I don't know why. So maybe I'll just escape this and I'll start with this piece. Do the same thing. I'll be like here, close this loop if I can. Okay. It's going to do the same thing. That one seems to connect okay. It's kind of weird. It's weird that it's like breaking up my line across that other line. Maybe this isn't a great example of how this works because it seems to want to be a little bit difficult to even though my loop is closed because I'm able to make my extrusion. So this is a poor example for some reason, but it mine is a closed loop, but it does have like multiple points that don't want to act like they are closed. But I know mine's working because I just went into it and I had my solid. Let me see again. So take me with a grain of salt is what it is. This does work for me sometimes. Sure. It already exists. So it's funny, it wants to add one, but it already exists. So I can say no, maybe. Yeah. Oh, I don't know. It's weird to me that I'm having these where these are intersecting. It's having kind of it's doesn't love this. If I change this one to construction, it probably would, but this one is really cutting my polygon. And maybe I should say, oh, let me check. My polygon really is from here. Close this loop. Okay. Yeah, it has to be your endpoints coming together, I think. And so this actually works for me, even though the closed loop function doesn't want to accept it, it actually is working. So maybe that only works when we truly have like point to point line up and I'm not cutting across this with other solid lines like I am here. So I think what I'm getting an issue is that I've got this going on for a strategic purpose, which is to break up my flange into a three-sided flange. So I'm going to say this is okay, but use that closed loop, use it as kind of a test if you're having, if you've changed a sketch and now the extrusion disappears on you. Go back into the sketch and see if you can close that loop, see if it'll help you troubleshoot it. Like me, I'm not having issues, so I probably wouldn't have even tried to proceed into this, but I just wanted to show you that I do use that from time to time, especially when I've broken constraints, like corner coincident constraints. So I'll say finish this. Even though my closed loop function isn't working, my solid is working as I'm expecting it. So I like this. Okay. And I've got 8 solids now. Okay. So this one I'm happy. This is kind of a little bit. I'm happier with this solid. The only thing that it's doing a little bit weird is it's taken this part because this discharge chute is a new solid. So before it was actually like kind of doing what I wanted it to do, where they were a join solid, and it kind of terminated the bottom of this trough going through my discharge chute. Now it doesn't do that because they're two independent solids, and so they don't cut each other off. So I might have to do a little. So what I do want is to cut that off because really I don't want this to be across my discharge chute. And so I'm going to do another quick like little cut modification on this, and I'm just going to cut half of this solid out from the discharge chute area, even though this is a solid area. And the reason is because I kind of want it. This is my original solid right here, and I want it to end up like this, like it's like the solid housing that we thickened here is not going across the discharge opening like this. This one won't do that way because just the way we've separated the solids, it continues through. So what I'm going to do is I'm going to do a sketch here on this end, and what I'm going to do is I'm going to sketch this profile like as a closed loop polygon, and I'm just going to cut this solid back to this face right here. Cut that out. So that I mean that's my original first extrusion is this one. And what I'm going to do is, but it's kind of a manipulation on that extrusion. So I'm going to do a sketch on this end of it. Try not to pick, the end. I'm trying to pick this actually solid. That is the solid right there, what's hanging up above here. So I'm going to select this for a new sketch. And I'm just going to F7 slice those graphics. So this is kind of me looking at the end of that first solid and the shape of it. And I'm just going to use its projected geometry here to make this cut. So all I'm doing is I'm looking to project like this right here. I want that line, and then I want this circular line here, like that. And these should be closed. And all I'm doing is cutting that much of the solid out from the discharge chute area. So I'm going to say that's all. It's just projected material. I have no dimensioning to do at all. I'm just going to say finish. And then I'm going to cut that though. So I'm just going to say cut, which is an extrusion cut here. Cut that solid. It recognizes me. That's my only sketch that I haven't consumed yet. So it's already recognizing that's it. And it's going to say cut how far. And I do want it to cut that solid, right? So it's that profile. The solids, it's so if I don't have it, it automatically selected that solid, but if I don't, this is where I would get rid of the solid and select which solid I want to use to cut that. It's this solid. And it goes yellow. And then I just need to tell it how far I want that little shape to cut. And really, I just want it to go 2. I'm going to use 2, and then I'm going to select this face right here as my 2 point. And there it just shows in red what's getting cut out of that solid. And it's going to cut it back to there. I'm just going to say okay on this. Hopefully it doesn't blow up on me too bad. Yeah. So I still have half of it up there, but really I'm using that mostly for these outside faces. And I don't have it down below in the other solid now. So I think I'm ready now to really go to my to make parts from it. So after even making that one part, I realized I had to get back into my solid, do a little bit of rework. I see some things I didn't love. So now I'm ready to say, okay, back into my part. I'm going to do a quick save on this before I leave it. Save it. Nothing's blown up. Everything's happy. It's time to use it. So here's my part. So I created this sheet metal part. This is the original solid that's in there. I'm going to swap it out though for my one that I've just newly created that has it broken up. And it's going to make that thick and blow up now because I'm going to change the base solid out from underneath it. So if you were here on yours, if you never did make a copy and you just reworked your other solid, then you won't have to swap it out. But I'm going to show this anyway because we won't probably do this a lot, but this is something that I will do a lot. But I have to be really strategic when I swap out solids because it has such a domino effect. And no, if I've made 15 parts off of this, then I pretty much have to go swap them out on every part. And so even though you swap out a base solid on one part, you may have to do more of that. So it creates a bit of a snowball effect to do this too. Not bad here at an early stage though. So what I'm going to do is swap this thing out. So what you have the option of, and I'm in the part, my original part. Here is the base component that showed up that we derived in, right? This is it. So I'm going to select it, right click on it. And then I'm just going to say replace base component is just a standard option you have on a derived part. I think we've messed with, you can open the base component from here. We can edit it and select different features to show up, and we can change how it displays in my part. We've done that a little bit, but here we have never done a replace base component. So I think this is a good place to try this. Replace base component, and then it just you need to tell it which base component you're changing it with. And I'll say, well, mine, I actually ended up having three because when I did rename mine, it did actually make another copy. So mine is called S2, was my solid that I really worked and I'm happy with it. That's it right there. So I'm just going to say open that, and then we'll just see what blows up. Continue with the replacement. Yes. And now, actually, it really modified my part for me without blowing up. I can't say that this does for everybody, but because the faces have changed, my part accepted those changes from the base component. So all I'm trying to do is peel back your brains a little bit and just open this world to you that there's a lot of functionality in Inventor. There's a lot of different ways to get there. And I'm just trying to highlight some of these kind of things we wouldn't read in our little Inventor book at all. And maybe it's just because they're just a little bit deeper, but it's really because people get better at it because they're used to working with more complicated assemblies where I have all these little tools available to me to kind of simplify some of the really complicated stuff and not always have to start from scratch. You find yourself as a bit of a troubleshooter more than you are just straight scratch, creating from scratch all the time. But all right. So I'm happy. I mean, I don't know how your guys' did, but mine, I'm super happy with it. Um, as far as that part there. Yeah, it was just a matter of I came in here and did a sketch on this sketch on the face where I wanted to start that cut. And my sketch was just projections. If I F7, all I did was project parts that I could see. I projected a line that was going across here because of that solid being a separate solid. It has kind of that top face structure in it. It's all buried in the solid. I get it. It's hard to see, but there is a line that I could project there, and then I could project, the U-shaped section of that. And those two really created a closed polygon that I could use to cut. So it's not even drawn material. It's all projected to cut. And when I did that, then I just chose to cut to this face. So I used kind of a cut to next, and I chose that face as where I wanted that cut to stop. Yeah. Heck yes.
What were your
Yeah, so back here on my part, my sheet metal defaults were I come in here to this pencil. So I'm on the sheet metal tab, right? Sheet metal tab. Go to the pencil here to actually edit or add. And then I created a new one, and I named it 12 gauge SS, 12 GASS, 12 gauge stainless steel. And then once you did that, you have to set the parameters for it, which the only thing I did is make sure it's stainless steel and make sure that it's the 0.1094 thickness. And then I just selected it here because now it'll be one that shows up on your drop down menu here now, rather than just the defaults. So you can choose to change the default to what you want, but I think it's better to probably create one that displays what it actually is. It's a little more visually understandable. My thought is that I think I'm going to continue to create parts in this part because there's another kind of trick that I wanted to show you, and I've alluded to it in weeks previous, and we've never got to a part to use it, which is just to kind of make it's going to be a little bit confusing here, but I'll show you what we're going to do. I think I'm going to so this normally when we would do stuff like this could be one part that I've made from that. It's like and I've technically, when I make this screw conveyor, this part will be its own standalone part. The sides of this as all one part are going to be one part. I really am not going to add the other parts that'll go to it. We'll have to probably weld it to it. And so I'm not going to, so I wouldn't make them here necessarily in a normal part file. You would just make what one part is and uh and then move on and maybe and some people would then just move to the next part, derive in the same solid and work from it. And we can do that. I mean, that's not a wrong way to proceed. But we can also use this as kind of our sheet metal part assembly, which is another confusing thing. So I have a solid underneath it that I'm using to make these sheet metal parts, but now I can make multiple sheet metal parts here, and then I can export them all as kind of the sheet metal parts of the housing. And then I can come back in and make so I might play with this just a couple of different ways. You have to remember I'm a little out of practice, haven't been in industry for a few years now, and I was doing Revit at NRF. So it's, sometimes I my inventor skills have to kind of come back as I work with them. And the way that I proceed is sometimes I rethink it and say, I wish I would have gone this way. So I'm gonna try a few different things here. I'm gonna finish this one part first though, which is it needs some flanges. So even though we didn't put them in our solid, we were planning on using the sheet metal ability to put the flanges on. And so what I have is I need to go back into I'm going to go canvas and our SEMA standard is what I need. If you remember when I was looking at the housing, it showed some of the flange dimensions that I was going to, there's a bunch of flanges on these parts that I'm going to add as sheet metal parts. And so let's start. So I'm going to pull up my resource here. So just a minute. Um, it's going to be the let me view this as you guys see. It'll just be in the resources section for screw conveyors or screw conveyor resources. So the manual that I'm opening up is the SEMA conveyor equipment PDF. I've already got it open here. Cool. I'm gonna go down into where the pages that had our kind of housing design in it, because it also shows the flanges. And we'll just see how this will work in. So I think it was pretty close to the end here, actually, before we got to the housing information. Right there, some of it. Yeah, right there. This is what page 33 of that document shows these B and then it has 3/4 of an inch. So this is what I'm going to try to replicate with my sheet metal tool is how to bend this. My trough just comes up and terminates here. Well, let's add this bend and add this bend to it. So these are flanges that kind of what I consider as a flange and a return. I mean, the flange itself, bending a flange on the end of this 12 gauge will stiffen up that edge to where it won't be so flexible. I mean, the edge that we have on our part here, this part right here, this edge, this is what I call is just a raw edge. And it's super flimsy on sheet metal. Like this thing is 8 foot long. And so this raw edge of this is super flimsy. It would just bow and wiggle and you'd be able to push it easily. 12 gauge is not super resistant to that. But if I bend a flange on there, it's actually super rigid. So I'm going to bend a flange and kind of rigidize this top section here. Plus, it makes a landing for like a lid to go on. So it kind of does dual purpose here. And it's a real common practice in sheet metals to bend flanges. We do a lot of kind of bending on sheet metal to stiffen it up, to rigidize it. Just for your note here, if you ever have like a long, like this isn't a super long distance here, but if this thing was like really tall and this side was really and this becomes kind of a dimensional thing that you'd worry about with a little bit of experience. But if this ended up being like a really like it'd be weird, but a really tall U-shaped trough, and maybe this was 2 feet up before the flange happened. Well, then I really am flimsy until I get to that flange. And sometimes what you'll see they do in sheet metal to help that out is they'll come in here and they'll come in here and it'll run like this and then they'll bend like a little V notch in it and then they'll come back and just like and they'll have to have material to do that. You have to like design it that way. But you can stiffen up a long section of sheet metal with kind of a V-shaped bend. They would do a bend and then a 90-degree bend and then back to a bend. So you actually put 3 bends in it with more material, of course, and you could rigidize sides. And where I would say to look for stuff like that is oh, I don't know, diesel trailers or like semi trailers on the freeway. I'm an idiot when I drive around, right? I'm always looking at like you'll get that way too. You're always looking at engineered designs. You're like, oh, why'd they do that, or why is that way? You'll see that if you look at sheet metal parts, big bins that are holding like in processing plants, like potato bins, pretty thin material, but they like bend, they do these like rigidizing bends across sheet metal to make it more rigid and structurally stronger without having to go to really thick plate that's overly expensive and overly heavy. We can stiffen up sheet metal with bending. Anyway, we were kind of using that concept to put a flange here. And so what I need to know is a dimension. B, zoom out a bit here and just see what my B dimension was. It's 1 and 13/16, which is an odd dimension, but I'm gonna do it that way to this, when I can use this manual, I'll use it. It's gonna help me hopefully hit this C dimension. And what I call the B dimension, that's 1 and 13/16, I call that kind of an outside to outside dimension. So we're gonna kind of pay attention to that and see and experiment with it in sheet metal if I can get that bent with the other bend that's also a 3/4 inch bend down that is kind of outside to the end raw edge. The reason why they would also add that other bend is to not have like a sharp edge towards you. If I'm the one, and we'll see that when we do our first bend, if you just leave that as a raw edge, it's just kind of a raw edge that could be sharp and somebody could cut themselves on or whatever. So they do these flanges and returns, really common, especially around access where human or where an access point might be. I'm just going to bend the raw edge away from someone that could cut themselves on it or something. So the secondary bend here also additionally stiffens this up, but it also prevents any just yeah, prevents anybody from hurting themselves on a raw edge. Raw edges of sheet metals are kind of sharp. So the thinner the sheet metal, the sharper they are, kind of. Okay. And then I want to end up with this C dimension overall from the edge to edge there, which they have called out as 14 and 5/8. So I'm just going to take a quick snip of this, even though I have it up. I'm just going to shoot this over on my other screen. So I'm looking for 1 and 13/16 and 14 and 5/8 finish with a 3/4 inch return. So let's go to our part here. Let's try to add those. And so these are on the sheet metal tabs. Sheet metal functionality is to add the flange, which we did way back when we were working in our book a little bit. So it's called a flange. Flange it. Of course, it opens up a pretty complicated menu here, but really I'm just selecting the edges first. And I can do this like if it's the same bend, I can select multiple edges, right? So to me, I'm going to select this outside edge, and that's going to drive the flange towards me this way. If I select the inside edge here, it's going to flange it the other way. I mean, we can swap that, but I tend to try to choose the edge kind of in the direction that I'm going, which so I feel this is going to be my bet, and it already is going that direction like that. So it applies that flange clear over to where at least it stops right here, and it's created a little gap because of some of our settings here. And we're going to maybe fine tune that. I might want to drive that flange all the way over as close to the corner as I can, actually, to this little edge here. But that'll be a fine tuning on the end. Let's just kind of make sure we get our dimensions right. A couple things I do like about this is I definitely have my solid here because I'm keeping track. This is how I want my this really, is my solid, and this is the top of the. I don't want to be above that. So the direction that it has, I like. So it's not like I don't want to flip it this direction. I want to keep it coming out. And then the placement of it, well, it's funny. I think it's interesting to click through these and see how that changes the bend. But from here, it's giving me a little longer distance. I'm like 1 inch, if you can see. It's measuring, kind of gives you that little measurement tool there. There's 1 inch from kind of the inside to the outside. My 1 inch here would be taken from a little bit different area, almost from the inside, maybe. That one doesn't seem to change too much, and nor does that one. So I'm going to keep that one on the first one for a minute. 1 inch. I do want it to be 90 degrees. The placement of this through partner edge, these ones also will affect the overall distance here, or where I'm taking that bend from. I'm going to keep it on the default one, which is this one right now. I'm just messing through the position here. That one is a bigger change here. This one is whether I'm above the top of my solid or I'm below it. I definitely want to be to where the bend is like this, to the top of my solid, not above it. So there's some things that are obvious that I don't want to do. And there's some things that don't have a huge change on it. But what I want to is I'd say, well, my thing says it's 1 13/16. So you could type that in as that, or I can type it in as 1.8125. That's 13/16. 1.8125. And I might have to play with this again because that's out to that edge. I need to add that other return on it. So that might impact it. I might have to come back in here and play with this. So let's just I'm going to pick this because it's just the dimension out of my manual, 1 13/16. And then what I don't love here is how this is cutting away by its default setting here. It's like cutting a relief here, which sometimes is helpful. In this case, I don't want it to be. Um, yeah, I'm going to kind of proceed on this whole project to kind of minimize any of these like big cutouts that it's going to do to they're relief cuts. But in reality, maybe I need those more on the thicker the material gets, or maybe the more complicated the bend gets. Right now, I want to keep it simple and just keep it like almost coming all the way to the edge. But so let me see what we can do. I'm not changing the bend radius. I'm going to keep the default K factor. I've got my sh Yeah, if I change this to tear, that's actually what I want to do here. I just want to consider that I'm going to, yeah, that's all I have to do is change that. Otherwise, if I do this one, I get a little circular cut, and this one I get a square notch cut. So I'm going to do a tear, and you'll probably see me do a lot of these tear. What I'm just saying is I'm going to make the laser cut that, but it's not going to allow me any relief, and so I'm just going to, yeah. Different places can have different what they want. Um, where I came from a lot, especially in the welding, that it's because a lot of times you're making welding joints here, and sometimes we don't like big gaps in weld joints on sheet metal, unless there's a really good reason to have a relief cut. But I can say that some companies will do things differently, though, and it's just something to be aware of. Is like how are my finishes, how are parts coming together? Um, and I didn't ever expand this one down. I do have more settings here. I don't think I have to change anything. I think I like this. The only thing I want to do is add the other side to it because it's the same kind of bend. So I really just want to add another edge set to it, which I think I can just select. And it'll have the same. So both sides of mine I'm bending like this with the same kind of features. And so that's my first flange. I'm going to say okay on that. So there we've got a flange. And that's just why we didn't add that to the solid, is because we're just doing the work in the sheet metal part. Now I need to add the return. Then I need to just make sure I'm not over 1 13/16 OD. So maybe I can, I'll just pick something and then maybe make an adjustment. But let's do another flange for the return. So that's that underside one like that. I think it preloads my last settings here. So I'll go ahead and select both of my edge sets here. Those are those two edges. They only need to be 3/4. That's 0.75. On sheet metal, there's also a minimum that you can bend. And so that is really dependent on the equipment that I have access to, but a good rule of thumb to keep in mind is you need at least like I would say um 8 times the metal thickness, maybe. Let me see what that is. If this is 12 gauge and it measures 0.1094, and I times that by 8, I think it's actually half of that. So I think I think if I divide that by 2, I think the minimum that it can bend is about 4 times the metal thickness, and that might be even a little tight on some dies. And some people's equipment, depending on their die and punch on their brake, would impact how short they can bend. So just know, though, and that's just what I'm pointing out to you here. There is a minimum that you can bend. I wouldn't be able to turn around and bend a little 1/8 inch flange on that on 12 gauge steel. It's not actually possible with the equipment that's available. So a good rule of thumb is like 4 times the metal thickness. So I could, and that would be seven, like 4.375 is 7/16. So it's kind of that kind of rule says the minimum little flange that I could bend 4 times the metal thickness. Um, Mine is 3/4, so I'm well within that range that I can bend 12 gauge at a 3/4 inch return. But if this thing goes up to a thicker plate, even I even have to go once I get out of sheet metal and get to plate, I have to even give more allowance for how short of a bend I can bend. And so these are rules that you'll learn if you work in this kind of industry, that there is a minimum. And so when I design stuff, I kind of have to be aware of that. And it's not something that you'll be intuitively aware with, but as you learn and have discussions with engineering and fabricators, if you work in that environment, that'll be one thing that is a big thing when you're working with sheet metal parts. You have to be aware of your minimum bend lengths, the minimum flanges you can put on. Yeah. Okay. Mine is 3/4, so that's good. And I want it to bend like very similar. I don't want it to, I can just set it to tear even though there's nothing that's actually tearing here. I'm just going to set the same thing though. It's going to look like that on both sides. 3/4. I mean, I set 3/4. I'll just say okay on this. I'm just going to do a quick measurement afterwards and see what I've got. So I'm going to say, okay, now measure this up. I'm targeting 3/4 kind of from that face to this face. I'm doing a quick measurement here. That is 3/4. So this particular bend and the way I've got it arranged in the in the settings is producing a 3/4 inch kind of outside dimension flange, and that's what I want. And then is it producing my 1 3/16 this way? Well, I can just kind of measure from here to here. It is 1 13/16. Sorry, 1 13/16. So my settings worked out. I just do a quick double check on this. Yeah, this is a good setting for hitting my target dimensions. So that might be the last bends on that. Okay. So now I think what I'll continue to do is like what I said was build and maybe I'll just call this a good point to stop and take a break for a minute. But what I'm going to come do back after break is I'm going to make a few more parts here and then I'm going to export these so that they become individual parts. So I'm going to kind of bundle them together, everything that's 12 gauge here. And we could even bundle together some of the 1/4 inch stuff. We would just do them as like instead of sheet metal, we would do them as 3D model extrusion. So I might do a couple different things here. I might build all of my parts right here and then export them all out. We'll see if that'll work for us. For sure, the sheet metal parts, I'm going to build them because I can get an idea of how they fit together here before I even individualize them. So I'm going to come in after we take a quick break. I'm going to make a little part here. This little part, I need a piece of sheet metal that'll span across. Of course, it's going to have to weld in. It's not going to bend in. So it's going to be a separate little small part there. And then on this end here, I'm going to make the three piece part around here I'm going to connect them all together. They're going to be like a U-shaped kind of chute for the discharge chute here. So I'll make and that, but it'll be a different part. It'll weld back to this housing. It's not going to bend into it. And so those are at least the next two parts I'm going to make. So let's see. I'll take a break and I'll call that part one. And I'll help anybody if you're struggling with something that didn't work out. Let me know.